This is Varun Dutt from IIT Mandi, and in this lecture on Large Applications Practicum, we will be continuing our discussion of tools and techniques which are relevant for large applications. In this particular lecture, I'll be telling you about our utility called Flex, which allows us to tokenize input and create a primitive compiler which allows us to actually do some calculation. So let's get started. So lexical analysis and parsing are two important steps in large applications, including in creation of compilers. Any application, particularly which we write, looks for patterns in its input and tries to convert the input into tokens. Generally, this is done by a utility in Linux or Ubuntu operating systems using Flex. And once the input is tokenized into small tokens, one can parse this, one can figure out how these tokens relate to each other. And this makes sense is done by another utility which is called Bison. So as scanning, which is often referred to as lexing, and parsing, which is done as understanding the tokens, are the first two stages of a compiler. People have been already using Flex and Bison for developing a large number of compilers, including PCC, Portable C compiler used for many of these Unix systems, GCC, GNU-C compiler, and others. And examples can be several, from a desktop calculator to an SQL database language syntax chatter, and we can write such kind of programs in Flex and Bison. So let's get started. So informally, scanning basically divides the input into meaningful chunks, and these chunks are called tokens, and parsing figure out how these tokens relate to each other. Let's say we write a statement in a programming language like C or C++ as int a is equal to b plus c semicolon. So what the scanner or the flexer or Flex is supposed to do is to convert this particular statement into this particular set of tokens, which is int type var, equal sign var, plus sign var, and a semicolon. So basically these capital letters are tokens which the program understands, whereas converting from this line to this line is the job of Flex. In contrast, Bison determines that we need to b plus c is an expression, and that this expression is to be assigned to be to the variable a. So we will look at Flex in this class, and we will focus on Bison in the next class. So particularly when we are writing a Flex program, we have to create a file which has a name, the name of the file .l, which is referring to by the Flex, which refers to Flex. And generally this file, which is some name.l, consists of three distinct sections which are divided by percentage symbol. The top part are the definition, the middle part are the rules, and the bottom part is the steps routine. So we'll see what are these three different parts, and we will discuss this further. So now you can actually see that this is actually a Flex program which had been written by us, and we will just shortly see what it does. So as you can see in this program, it is counting word count fp11.l is the name of the file, and see, first part in the program has this percentage bracket open bracket percentage bracket closed, and this part, as I was telling you, are the definitions part. So this part is basically creating different variables, and sometimes this part is copied as is into your C program, which will get created from the .l program. This part, the middle part, is a set of rules, and as you can see, we have defined regular expression like rules, which says all A to Z letters or capital A to Z letters followed by more symbols of the same kind. So this basically construct increments words, and it also sets chars to be the length of the particular word, which is in front of the Flex program in the input. And then this \n means that if we are going to the next line, so we'll count it as a character and also count it as a line. And then dot means that we will count it. For anything else, we will also count it as characters. So basically this is counting words, lines and characters in my program, in my input. And then the third part, which is the subroutine part, here we will write the main part of the function, which will call something called bylex, which is the flex program, and it will print the line, words and char. So this part again will be copied verbatim into the C program, which gets converted or created from the .l file. This is just defining each of the parts, and you can see that the definition section contains the definition and assignment of variables, and typically this code is copied verbatim near the beginning of the generated C source file, which you will just see shortly. And in this case, it sets up variables for line, words and characters. We also have a rule section, and the rule section basically consists of these type of patterns, which allows us to, each pattern is at the beginning of a line, followed by the C code, which will execute to be able to parse what is the pattern matching to. And the C code can be in one of the statements, or it can also be possibly a multi-line block with the braces around it. Each pattern must start at the beginning of the line. Always remember, beginning of the line says flex considered any line that starts with white space to be code to be copied into the generated C program. And this type of patterns are written on a line, or it could be written with multi-line block as well. So then we have the third part, which is the rules part, and in this particular rules part, we have the variable y text is set to point. So in this particular case, one more thing is to be understood, that there is actually a special type of variable called y text, and this particular variable in flex is supposed to point to the input text that the pattern just matched. So for example, if there is a word and that, like Barun, and that word was in the input, and the flex just matched that pattern, that word to that pattern, so y text will point to that input text Farun. And a to z plus matches a word of one or more characters. This is basically what it means, small k for capital case, whereas a to z will match a single character in a word. So remember, this is single character in a word, which could be from small a to z or capital A to z, and followed by one or more. The plus sign means one or more such characters in a word. And that is how we define the rules. And the subroutine section can contain functions of any other code to be copied. Bylex is the lexer flexer function, which is the lexer function, which does the scanning until a return is encountered or the rule matching is complete. So either a return is encountered or rule matching, particularly all the rules have been matched and the input, there is no other input in it, and therefore bylex will come to an end, and then we print the line, words and chars. So how do we run this program? So first, to run this program, we will have to install flex, and in Ubuntu installation, sometimes it is built in, but for installing flex, you can write sudo apt-get install flex, and then you can write sudo apt-get install bison. And once flex is installed, you will call flex with that .l file, and then you will call the C compiler. So this line of code will convert the .l file into a .c program, which will have this name, and then we will compile this C program using the lfn flag, and then it will get compiled to a output file called a.out, which we will run. And you can see that here we have given an input on the prompt. The boy stood on the burning deck shelling peanuts by the peck, and you can see when we do Control D, it will print out 2, 12 and 63, which is the number of line, words and characters in this input. So this basically allows us to count this particular, so this is a primitive compiler which we have written, which allows us to use flex to count the number of lines, words and chars in this program. So now, what are the different regular expressions possible? There are a number of regular expressions which the flex allows us to create. Dot means any single character except new line, which we have seen. \n means new line. Star means 0 or more copies of the preceding pattern. Question mark means 0 or 1 copy of the preceding pattern. Plus means 1 or more copies of the preceding pattern. We have seen the plus in the previous example, but we could also put question mark and star depending upon 0 or 1, 0 or more, or 0 or 1. And this this power symbol matches a pattern at the start of a line, and it is often used as a negation. So if we write in this case, if we write not with the power symbol, it means not any of these, means a name or some word which doesn't have alphabets in them. And dollar means matches the end of a line as the last character of a regular expression. So one character, and this is A or B. This is literal A. It will match A in its own. And this is the character class which we have used, for example, like this to define a set of characters. And then we can also write like this, all characters in first class minus the characters in the second case. So this is like A minus B. It means all things in A which are not in the set B. And this is also available in the latest versions of Flex. So the question is that lexical analysis also comes up with a set of functions and a set of variables which we can create. And here we have YYLex, which is to invoke the lexer flex, which we have seen in the main program in the last example. I also told you that there is a special pointer which is called YYText, and it shows generally the string which it matched to at the end. And then we have the YYLeng, which is the length of the match string which the YYText is pointing to, and YYLval, value associated with the token, YYWrap to return 1 if done scanning, else return 0. We will look at these in the next class with Bison. And YYIn is a flex read from stdio file called YYIn. Thus to read any one file, you need to set YYIn to that file before the first call to YYLex. So the idea is YYIn is a way of reading the input from a file rather than from a prompt, and then we can call YYLex. So here is another example of a flex program. It's converting British English to American English. So if it founds a color, it will make it color, flavor, without a U, clever, smart, elegant, liberal, conservative, and it will print the text. So if you run this, and you can call YYWrap return 1, which means return 1 if done scanning, else 0. So if this is called once it is scanned, and then it will return true. And you can see that whenever you pass an input, it will actually match these patterns. And if it matches any other word, it will just going to print that word. So you can see we have written a program for converting from British English to American English. Similarly, we can write a program which will recognize tokens in a calculator like plus symbol, minus symbol, numbers from 0 to 9 followed by one or more such numbers, and anything else will be printed as a print mystery character. So this is a simple calculator scanner which we can also create in Flex. So now Flex generates the scanner for you in C, but there are other variants of Flex for generating scanners in different languages. Like for example, we have JFlex for Java. We will cover also a parsing tool next class called Bison to generate parser next week, and then interface the lexer and the parser together to develop some useful programs like command line calculator. I used this resource for creating this lecture, which is the standard book, Levine's book for Flex and Bison. I would like to acknowledge all the TF for their help. And this is also the link to install Pit test or Pit clips, but you can also install the mutation testing tool from the Eclipse marketplace in the Eclipse editor. So now we will get to the activity of this lecture, and in the activity of this lecture we are going to look at how Flex works. So first install Flex. So you'll test update, install Flex, also install M4 macro processor. Typically it's used in Ubuntu, and if you're using Cygwin, which is another emulator, you can do so. Otherwise you can use the Linux built-in application in Windows like I showed you in the previous lectures while discussing make utility. And what we need to do, we need to write the program given in the lecture for counting character, words and lines in a program, compile this program and run. And then second, we need to extend an existing lexer on calculator scanner, and you can also create multiplication symbol to division symbol and empty space and tab character in the input also into tokens. So this particular example we need to extend. So please try these out on your own, and we can actually discuss. So there's one more thing which is bonus to write a flex program to tokenize information given in the sample5.txt file. Your program should return the following tokens. So there is a file given where this is a program given, and what you need to do is to convert the entire program into a set of tokens like this. And so you need to basically write a flex program to recognize this and convert this into a output tokens. And what you need to generate, so you may also want to use in this case, because there is a sample5.txt file to be read. So you can use it with fopen with argv1 in read mode, and then read it, and then you can call the lex in the main part of the program to run it. So please try this out, and we will connect again in the next lecture. Thank you so much.